Hello and good day, learners. I am Kaya Sacapaño, and for this lesson, we will be learning about parity codes. So first and foremost, a binary word is considered as an even parity if the number of ones in it is even. On the other hand, it is considered as an odd parity if the number of ones in it is odd. So take this for example, we have 1101. So there is a total of 4 ones in it, and 4 is an even number, which makes this parity an even parity. Next, we have 10101, and the number of ones in this parity is 3, which makes this an odd parity. Next, we have 001, which is also an odd parity because we only have 1 1, and 1 is an odd number. The next one is 100100, which is an even parity because we have 2 ones and 2 is an even number. So here is what you should take note of in error detection by adding parity bit. First is that in the sender's end, the sender counts the numbers of ones in it and adds the parity bit in the following way. In case of an even parity, if the number of ones is even, the parity bit value is 0. If the number of ones is odd, the parity bit value is 1. In case of odd parity, if the number of ones is odd, the parity bit value is 0. If the number of ones is even, the parity bit value is 1. So let us take this data frame for example. We have 1001101. So since this is an even parity bit, we will only be adding 0 since we already have 4 ones, which is even. If we want to make this even parity bit into an odd parity bit, we will add 1, because if we add 1, we will then have 5 ones, which will make the parity bit odd. So on the receiver's end, the receiver counts the numbers of ones in it. In case of an even parity check, if the count of ones is even, the frame is accepted. Otherwise, it is rejected. In case of odd parity check, if the count of ones is odd, the frame is accepted. Otherwise, it is rejected. So the receiver will decide whether an error has occurred by counting whether the total number of ones is even. 3 cases may occur, namely no error, single bit error detection, and failure to detect multiple bit errors. So this is illustrated as follows. Take these cases as the received frame for example. So in the first case, we have 100111010. So here we have 4 ones, which is an even parity because 4 is an even number. So we will then decide, the receiver will then decide that there is no error because the number of 1 bits is 4, which is again an even number. In the next case, we have 100111110. So there has been an error detected because the number of bits is 5, which is not even. And in the third case, we also have the failure to detect an error because the number of 1 bits is 4, which is also even. So let us take this for example. We have received a message after source encoding, which is 11, 10, 01, and 00. So we have our channel encoding right over here, which is x sub 1, x sub 2 is then x sub 1, x sub 2, y, provided that x sub 1 plus x sub 2 plus y is of the same even parity. So y is your message, and x sub 1 and x sub 2 is 1, 1 respectively. So here we will be putting our first message, which is 1, 1, and considering it is of the same even parity, we will only be adding 0 since 1, 1, 1 plus 1 is equal to 2, which is already an even number. So we will only be adding 0. In the next message, which is 10, we will be adding 1 because previously there is only 1, 1 and 1 is an odd number, and when you add these two together, its sum is equal to 1, which is an odd parity. So we will be adding 1 so that we have 2 ones, making it an even parity. Next message, we have 01, where we will also be adding 1 since previously it only had 1, 1, which is an odd parity. So adding 1 more 1 to it makes it an even parity since there will be 2 ones, and 1 plus 1 is equal to 2, which makes it an even parity. And lastly is 00. So since 0 is an odd number, we will be adding 0 to this parity, which will remain as an even parity. After doing so, we will have our even parity code. C is equal to 110, 101, 011, and 000. So for the next example, our message after source encoding remains the same, but the channel encoding requires that it is of the same odd parity. So we will again change the parity, but this time into an odd parity. So here we have 1, 1, which is an even parity, so we will be adding another 1 to make it an odd parity because 1 plus 1 plus 1 is 3, which is an odd number. Next, we have 10, which we will then be adding 0 because we have 1, 1, which is already an odd parity. Next, we have 01, which we will then be adding 0, considering that it is already an odd parity. Lastly, we have 00, where we will be adding 1 to make it an odd parity. You will then come up with the odd parity code C is equal to 111, 100, 010, and 001. So let us take this last example for the error detection for parity codes. Suppose that Bella sent her message Y using an even parity code. Dave received the binary word R is equal to 0111, 0110. Is there an error in the transmission? So yes, there has been an error in the transmission since the binary word 0111, 0110 has 5 ones in it, and 5 is an odd number, which makes this an odd parity code.